What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 6, Section 3, Logarithmic Functions. Let's do it. So a base b logarithm would be something like this, right? Log base b of x equaling y. And so what does this mean? It really is just a reformatting of an exponential equation, because this is the same as saying b to what power equals x. It's two ways of writing the exact same thing. So when you're saying base b logarithm, like in this case, you're saying b being raised to some power, we can call it y, is going to equal this x value. So that's the relationship done. So for this one, how would we apply properties of exponents to solve this? First, I'm going to write it in its exponential equivalent form, which is that base b to the y power equals x. And then we could solve it this way. Now, I'll give you an example. If your b was 2, for example, right? Let's say it said log base 2 of x is equal to 3. So the way we would do this is we'd say 2 to the third power equals x, right? B would be 2, y would be 3. And then 2 to the third power, you just evaluate it. That's 8. So then x would equal 8. So that's an example of how you would do it. For this one, it says, what is the meaning of the natural logarithm? And that's given this format, right? ln, log naturel or natural log. And it's just like any other logarithm, right? So let's say we have log base 2. You would take your argument. Let's say it is 5, and that would equal x. So this is really asking 2 to what power of x equals 5. So a natural log is the same type of thing, except for now we can also rewrite a natural log as log base e. So that's the key. Natural log is a regular log, like this is log base 2, but if we did log base e, we can just rewrite it as ln. So it's a nice little shorthand. And then one example might be log base e of e squared. And I'm just giving you this example because if you remember, e is a number like 2.71. It goes on and on, right? So the reason why this will make sense is because this is saying e to what power equals e to the second power. Well, of course, that would be 2 in this case, right? And in the same format, ln of e squared would same thing be 2, right? It's asking e to what power is equal to e to the second power. So that's how the notations relate. Done. So this one we're going to rewrite in exponential form. And again, it's that base of the log a to the power of the opposite side, which is c, equals the argument of the log function, which is b. That's how you do it. Done. For this one to rewrite it, we say the base, which is x, to the opposite side to that y value as an exponent equals 64. So that's the conversion. Done. For this one, we convert it to the exponential form by taking the base of the log, which is 15, raising it to this power, which is the value on the right side of the equation, which is b, equals the argument of the logarithm, which is a. So there's your answer. Done. So for this one, to convert it to exponential form, we take that 13, that base of the logarithm, we raise it to this power, which is a, and that equals to the argument of the logarithm, which is 142. There it is. Done. For this one, we start by finding the base of this logarithm, but it's not really there because it's natural log. But we remember natural log is the same as log base e, and then of w equals n. So now we know the base. Natural log, it's e, but now it's written out. So we say e to this power, what's on the other side of the equation, to the n power equals the argument of the logarithm, which is w, boom, done. So for this one, we're going to rewrite it in logarithmic format. So it's log base something of something equals something. Now, the exponent, that d value, that's going to be what goes on the other side. And then this value, c being raised to an exponent, that's your argument of the log. And then last but not least is that k value. So this again asks, if we convert it back, you'd say c to the d power equals k, which is what we have here. So that's how you convert it to logarithmic format. Boom, done. So when we convert this to logarithmic format, first we need to know what the base of the log is, and that is this value right here, which is being raised to an exponent. So we know the base is 19. Then we have this value here, okay? The y value is actually the argument of the logarithm. That's going to go in here. And then the x, which is the exponent, that goes out here. And if you remember, as when we were converting from the logarithmic to the exponential, it's always base to this power, which equals y, which is what we have here. So this is how you do it. Boom, done. So for this one, as we convert it to logarithmic, first we're going to start with the base of the logarithm, which is the same as the base of this exponential. So it's it's n, which is log base n down here. Then the 103 on the other side of the equation, that's actually going to be the argument for the log. So it's log base n of 103 equals, and then the remaining part is the exponent. So that's how you convert it, and just converting back to exponential, you can see it works, right? You take the base of the log to this power equals this, which is what we have up here. So this is the final answer, done. So for this one, as we convert it to logarithmic, again, my base of the log is the same as that y value, right? The y value being raised to an exponent. So it's log base y, and then it's the 39 over 100, the side on the opposite side of the equal sign. That's my argument. So 39 hundredths equals that remaining x value here. And again, if we remember to convert from logarithmic back to exponential, it's this to this power equals this. And that's what we have in the original. So here's the logarithmic form, done. For this one, as we convert to logarithmic, we take the argument of the log to be this value here that's being raised to an exponent, so that's e. Then we take that h value on the other side, that's the argument of the log, and then that equals to the exponent, which is k. But the good news is log base e can be rewritten in a simpler format, which is natural log, aka ln. So then we have ln of h equals k, and there's your final answer, done. So for this question, we're meant to solve for x by converting this to the exponential equivalent. So again, it's the base of the log raised to this power on the other side, so it's 2 to the negative third equals x. So what is 2 to the negative third? If you remember negative exponents, it's really 1 over 2 to the positive third. That's another way to write it. 2 to the third is 8, which means x equals 1 over 8. Boom, done. So to solve this one, first I'm going to convert it to its exponential equivalent. So it's the base of the log 3 raised to that as an exponent. 3 to the third equals x. So what is 3 to the third power? 3 times 3 times 3, which is 27. That's how you do it. Done. For this one, to convert it, we convert it to exponential format by taking the base of the logarithm 9 raised to that power over here to the 1/2 power, which equals x. So 1/2 is the same as taking the square root of 9, okay? So now we can take the square root of 9 and we get 3. But again, it's kind of like plus or minus, right? So maybe we might say there's two solutions. But here's the thing. We can't actually take a negative value as an argument of a log. It's not possible because think about what you're saying. You're saying 9 to what power, what exponent equals a negative number? Well, there's no such there's no such exponent like that can flip the sign to a negative. So we're only taking the positive side of the root, which is 3. Boom, done. For this one to solve, first we're going to convert it to exponential format, which is the base of the logarithm raised to this power equals x. And for a negative exponent, it really means 1 over 6 cubed. And since 6 cubed is 216, it's 1 over 216. That's how you do it. Done. So for this one to convert it, we got to take our base, raise it to that power, set it equal to x. But there doesn't appear to be a base, but when there's no base and it's ln, it's really a base of e. So that means e to the second power equals x. And since they want the exact answer, we just leave it as is. Boom, done. So for this one, we can solve by converting this into logarithmic format. Okay, so check this out. Again, for this equaling some y value, right? If we think about it, it's log base, whatever this is, which is 10. So log base 10. Even though regular log implies base 10, we'll still write it. So log base 10 of something, that's the argument here. That's the y value equals, and then we got log of 32. But remember, when there's no base written, it is the same as log base 10 of 32. And now once we get it into this format, you see they're actually almost equivalent on both sides, except for we have y here and 32 here, which means if these two sides are equal, y must therefore equal 32. And again, y is a value that I just added in. So the actual value of this expression, we can just simply write as 32. So for this one, I'm going to convert it into its exponential equivalent. First, I'm going to take log base of this value here. And again, imagine this being equal to a variable. So log base e of x. That's how we're converting it, right? To the thing on the opposite side of x equals, and then we have ln of 1.06. But the thing that you need to remember is ln is log base e. So really what we have is ln of x equals ln of 1.06. And if these two are indeed equal, that means x has to equal 1.06. And again, I kind of added x. I turned it from an expression to an equation. Really, this x is just the value of that expression, which is 1.06. Boom, done. So for this one, we're starting out with this whole thing equaling x, and we're going to convert it into a logarithmic expression. I'm going to start by subtracting 4 from both sides. Now I'm going to convert this to the logarithmic equivalent over here. So on the left side, e to this thing, it becomes log base e, and then it's of what's on the other side, which is x minus 4 equals ln, that exponent, ln of 10.125. Now, the good thing about ln and log base e is they're the same thing. Log base e is natural log. So now I can say natural log of x minus 4 equals natural log of 10.125, which means if these two sides are indeed equal, this expression is equal to this. So x minus 4 equals 10.125, and then to solve for x, we just add 4 to both sides. Again, x was something I added in. Really, x is what the value of this expression sort of evaluates to, which is 10.125 plus 4, which is 14.125. Boom, done. So for this one, we're meant to evaluate it without a calculator. So the way I'm going to do it is I'm going to say that this is going to be equal to some value, and I'm going to use this to convert it to exponential form. It's going to make it easier. So this is saying 6 to some power x equals the square root of 6. Now, what is the square root, right? If we write it as a power, it's really 6 to the 1/2 power. And then now that we have it laid out like this, well, of course, x must equal 1/2 if these two sides are going to be equal. So x equals 1/2, which means this thing evaluates to a value of 1/2. Boom, done. To solve this one, I'm going to start by setting it equal to some unknown variable. Next, I'm going to divide both sides by 6, so we get log base 8 of 4 equals x over 6. Now I'm going to convert it to exponential format. So I'm going to say 8 to this as an exponent, x over 6 equals 4, the argument. Now the problem is these are not the same values, but if they were, this would be nice and straightforward, but they're not. However, I can write them as powers of 2. So 8 is 2 to the 3rd power, whereas 4 is 2 to the 2nd power. Now I can use my exponent rules here with the parentheses. These guys multiply. So 3 times x over 6 is 3 over 6x, which is the same as 1/2 x, equals to 2 squared. Now, since I have 2 and 2, I can kind of remove the bases and just set those exponents equal to each other. 1/2 x equals 2. To isolate x, multiply both sides by 2, and we get x equals 4. And again, that was the variable that I created to set equal to the value of this expression. So the bottom line is the value of the expression is 4. Boom, done. For this one, we're evaluating this expression, and remember, when there's no argument, it's really log base 10 equals log base 10 of this, which as an exponential format is 10 to some power equals 0.001. So maybe to write this out as a fraction might be a little bit easier, because 0.001 is 1,000, which is 1 over 1,000. Now, what is 1,000 as a power of 10? It's 10 to the 3rd power. So I can write this out a little bit better as 1 over 10 cubed. And then now I can do even better, because when you have an exponent in the denominator, it's the same as 10 to the negative 3rd. So 10 to the x equals 10 to the negative 3rd. That means that x must equal -3. So this, therefore, evaluates to the value of -3. Done. So to solve this, I'm going to show you a little bit of a shortcut here. So we have 2 in front, and this log is really log base 10. Okay, so when there's no 10, it's log base 10. And then we have 100 to the -3rd. I'm going to make this a little bit easier by writing 100 as 10 squared, okay? And then it's that value to the -3rd. So we're going to write it like this. I'm going to show you why this is. We can take a little shortcut. So then we can simplify by multiplying those exponents. So we have 2 log base 10 times 10 to the -6. So the reason why this is cool is because, remember, log base 10 of something is really asking the question, 10 to what power equals this? So it's saying 10 to what power equals 10 to the -6? Well, of course, it's -6. So this is a nice thing that we can simplify right off the bat. That just becomes -6. Then we have 2 times -6 equals -12. So that's the value. Now, the other way you can think about this is, again, we can just set this equal to a variable, divide by 2, right, to get rid of that 2, and then follow that same protocol that we did before. This would say, to convert it to exponential, 10 to the x over 2 equals 100 to the -3rd. And then we'd go down that same path. 100 is really 10 squared. So this is 10 squared to the -3rd, which is 10 to the -6, equals 10 to the x over 2. Then you set x over 2 equal to -6, and you see you'll still end up with that same value of -12. That's 2 ways to do it. Done. So for this one, we're meant to evaluate natural logarithm of 1. And the cool thing is any logarithm, it doesn't matter what the base is, any logarithm of 1 is actually going to equal 0. So that's what this equals. But I want to explain a little bit more why. So if you remember that a logarithmic can be expressed in exponential format if I just set it equal to x, and then it's saying the base of this log, which is e, to some value that's on the other side to the x equals 1. Well, the reason why this makes sense to be 0 is any number to the 0th power is 1. I don't care if it's 10, if it's 100, if it's a million. So that's why any logarithm of 1 is really saying its base to what power equals 1. It's always going to be 0. So 0 is the answer. Done. So for this one, we're going back to that shortcut rule where if I have a logarithm with a base and then I'm taking that same base to a certain exponent inside, that's just going to evaluate and cancel out to just be that power, which is 2/5. And then we can say 2/5 times 25, that simplifies to 5 over 1. 5 times 2 is 10. So that's using the shortcut. But now if we go back to the method I was showing you guys before in previous examples, if we set this equal to x, we can also solve it by converting to exponential like this. So you imagine, first I'm going to divide both sides by 25, and then I have ln of e to the 2/5 equals x over 25. Now to convert this to exponential, remembering that natural log is really base e, we're saying e to the x over 25 equals whatever we have in here, which is e to the 2/5. Now I can set these two exponents equal to each other because we got e and e. So x over 25 equals 2 over 5. We can do a little cross multiplication. 5x equals 50, which again gives us a value of x equals 10. So 2 ways to get to the same answer. 10 is the winner. Done. For this one, we're meant to evaluate using a calculator. So I'm going to plug it into Desmos and we're going to get an approximation. So here we have ln of 15 is to the nearest thousandth, 2.708. So 2.708, boom, done. So for this one, we're going to approximate using Desmos. So I'm going to plug it into Desmos. So here it is, log base 10. Again, when there's no value written there, you assume it to be 10 for log. So log base 10 of the square root of 2 gives us 0.1505, which can be rounded to 0.151. So 0.151, boom, done. So for this one, it says is x equals 0 in the domain of this function. So what is it really asking? It's saying, can you actually calculate log of x? Can you take logarithm of any base when x is 0, right? Can we take log of 0? And the answer to this is no. And I'm going to explain why when we convert it back to its exponential equivalent. So again, in this example, it's log base 10 of x, and this equals some function value. And we're trying to figure out, for some function value, let's just call it y, we're trying to figure out, can x ever be 0? So they're saying, is this possible? Now, first I'm going to convert this to its exponential equivalent, which is the base of this logarithm 10 to the y power equals 0. So is there such an exponent? Let's think. If y is 1, it'd be 10, 2, 100, 3, 1,000. So that's going in the wrong direction. What about -1? Then it'd be 1/10. That's getting closer. What about -2? That'd be 1/100th, 0.01. So you can see that we're getting closer and closer to 0. But the question is, do we ever reach it? And the answer is no. We get very, very close, but an exponent can never drop something to 0. It can drop it to 1 over some huge number, which is close to 0, but never exactly 0. So we would say the answer to this is no, it's not in the domain. That's why, boom, done. Is there a number x such that ln of x equals 2? If so, what is that number? So again, what I'm going to do is I'm going to write this out like so, and I'm going to try and convert this to its exponential equivalent to see if we can figure this out, remembering that ln is really base e. So to convert it, it's e to the second power equals x. Which means, yes, there is a number, and it's e squared. So that's the number. And again, it does have an approximation if you plug it into Desmos, but this is acceptable. And to verify, we just plug and chug in for the original equation. So ln of e to the second equals 2. Again, this makes sense, right? It's saying base e to the second power equals e to the second power. So that's how you verify. Is the following true? This over this equals this. So let's think about this. First of all, what is ln of 1? That's something that we talked about in a previous question. The logarithm, any logarithm, regardless of the argument, right? ln base e, log base 10, whatever, any log of 1 evaluates to 0 because It's asking the question, e to what power equals 1, or 10 to what power equals 1. And the answer is any number to the 0th power is 1. So that means ln of 1 is 0. So that means we've got ln of e to the 1.725 over 0. Now, ln of e to the 1.725, again, when the base is the same as this value in here being raised to an exponent, these essentially cancel out. So you're left with 1.725 divided by 0. But this does not equal 1.725. 1.725 divided by 0 is undefined, which means that we cannot verify the result, meaning this is not true. It is false. Boom, done. So for question 65, it asks us to refer back to this equation in question 64, and then it's giving us the following values. It's saying EI is -2, time is 16, which is t, and then we're solving for f. So let's plug and chug. So now we've plugged in as follows. Next, what I'm going to do is I'm going to convert this into its exponential form. So it's this base of the logarithm, 2, raised to this value, which is to the -2, equals the argument on the inside, which is f squared over 16. Now what we can do is 2 to the -2 is really 1 over 2 squared, which is 1/4. So I'm going to rewrite this as 1 over 4 equals f squared over 16. Then I'll do a little cross multiplication. We got 4f squared equals 1 times 16, which is 16, divided by 4. F squared equals 4. Last but not least, we're going to take the square root of both sides, and we're going to say f equals +2. Now, you might say, what about -2? But my assumption is that for this, we actually don't have a negative setting, so the negative value wouldn't make sense. So we're going with an f-stop setting of 2, boom, done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.